Alright guys, we're going to go ahead and do a couple more of these regression problems. So if you were looking at this worksheet, we're going to go through two problems here. Now the first two are review. This was literally done yesterday, so I'm not going to go back and review the exact same things again because we're just basically building on what we did yesterday. So what we're going to do today, so we're going to jump down here, we're going to go all the way to number 3, and all we're really doing, we're doing the exact same steps as we did yesterday. The only difference is, you will see as we go through this, we're going to be doing a cubic model and or maybe quartic or quintic models and things like that. So it just really changes one step. So overall this is review. So anyway, looking at number 3, we're going to have the same type of data. This represents the number of people in line for a roller coaster here. So we got the Millennium Force at Cedar Point is one of the world's most popular roller coasters, and the table below shows the average number of people in line at each hour after the park opens. So what we're going to do is we're going to take this data and we're going to input this data into our calculator. And when we have that data, they're asking us to use a cubic model to find an equation to give you that curve of best fit. So let's go ahead before we start this. Well, actually, to start this, honestly, we need to take this data and enter it into our calculator. So let's start off, and again, follow along with me. As you do it, you're going to hit the Stat button. So hit Stat, and we're going to go to Edit, Stat, Edit. And we're going to go to our data. Now this data, we need to make sure under L1, that's going to be your X values. So we're going to type in all those X values from 0 to 5. So 0, 1, 2, 3, 4, and 5. So we got those 5 points, and I'm going to hit our right and up arrow here to get back to the top of L2, and we're going to type in our Y values. So 0, and then 120, 324, 375, 2 more here, 394 and 312. Alright, once we have that data entered, we can go ahead and hit second quit. Let's get back to that main screen, and as I said, we're going to have two options here. But what's happening though is we just plotted a bunch of points, and you can go to your graph if you wanted to see it, and you can see those points, but I can give you a brief rundown. We got 0, 0, say 1, 120, 2, 374, which is way up high, or 324, 3 is going to put us even higher, 4 is going to put us even higher, and 5 is going to bring us a little bit lower. And again, it's just giving you an idea of what we're looking at as we are doing this graph. Okay, and when you have a cubic model, it's just going to see, like, we're going to have maybe something like this, or maybe they'll have the model come up here. I don't know. You know, the nice part is the calculator kind of makes it fit as best it can. But the portion of the model we're going to look at is basically going to be this piece. Okay, and it's going to try to fit it as best it can fit it. And it's going to model, again, how many people are in that line throughout the day. So anyway, let's start by getting that equation. So I'm going to go Stat, Calculate. So I'm going to go over to the right hand side, and because I want a cubic model, this is really all that really changes in this lesson today. Is we're going to do, instead of quadratic regression, we'll do cubic regression. So we're going to hit 6 instead of 5. Again, hit enter until you calculate that regression equation, and there it is. So you can either type out the equation, write it out by hand, which this would be kind of annoying. I'm not going to write the whole thing. I'll just go 5.2x cubed plus 7.78, so that's 7 repeating, x squared, plus 154, 0.5x, and then minus 8.2. Now again, we want to have the actual equation used, not just this little guy where the numbers are all rounded off. So we're going to go into our y equals screen and clear the old equation that we had, and this is where we copy and paste. So to do that, we hit vars, variables, and we're going to go to statistics, which is option number 5. go hit your right arrow until you get to equation, and regression equation should pop up. And it should copy that equation in there for you. Last thing we need to do is we need to get our window. Now, this is where I like to say I have this graph now, and I can kind of show you the window that we're looking at. First off, the graph that I just labeled, where I just labeled the points. Remember, we went out to 5 because that was this point out here for our hours. And our y values, they kind of went up a little bit. So they're up here around 400. I know that's actually up there. It's a little higher than that highest point, but you get the idea. So the highest it gets is 394. So I'm going to go to my window. I'm going to go from 0, and let's go out to maybe 10. I know the question, if you look at the question, they want to estimate the number of people in line 6 hours after, so you don't need to go to 10. But that just gives me some space to work with here. So I'm going by tens. I'll make my scale 1 since 10 isn't that big. That's my little tick marks represent 1 unit. My y values, I'm going to go from 0, because I do have 0, 0 as a point, and I'm going to go all the way up to 400, and that should fit everything. And I think my y scale 50 is still good, so I'm just going to keep that, and I'm going to graph. And there you go. And again, obviously this graph is just a portion of it. I mean, as you go off the screen, it may come back up like this because it is a cubic graph. Or maybe that graph is, well, it was a positive, right? So yeah, it's going to come back up over here somewhere. I mean, that's really the whole thing. But we're only, again, it's fitting based off the data we have. The more data we have, the more accurate we maybe can make this model. Obviously, it's not going to shoot up forever, but that's okay because it does fit in the domain that we have. In the domain that we have, this equation does fit the data, and that's what really matters. Obviously, we don't want to go out to like 500 hours, but of course, the park wouldn't be open for 500 hours either. So, you know, within the realm of what we're looking at, this data does fit very well. So, now that we have that, I want to know or estimate the number of people in line 6 hours after the park opens. So when x equals 6, I want to know what my y value is. So we're looking for the y value, which is the number of people. So remember, on a situation like this, go to your table. Now, before I do this, remember if you go to your table setup, second window, table setup, as long as you have your independent variable set to ask, your graph or your table will look like mine. And I want to plug in 6 for 6 hours. So hit 6, and we have about 75 people. So this is going to be approximately 75 people are going to be in line. So it looks like it's kind of starting to go down, and that might be the time to go. If you didn't get there the first hour, just wait till later in the day after everyone's kind of gotten on it and they're riding all the other rides. So that's going to be number 3 using a cubic model. Okay, so that's number 3, and then make sure you have that answer ready to show me. And then we have, lastly, I want to do a quartic, so we're going to do number 6, and those are the 2 we're doing. Okay, so number 6, this is that one that has, instead of times, it has years. And remember what I said to do with the years is take this first year, and we're going to call this your t-value, and your t-value is going to be 0, and then 1990 is 2 years later, and then 3 more years is going to be 5, and then 2 more years is going to be 7, 4 more years, oops, is going to be 11, and we have 6 more years after that, so that's going to be 17. So we don't want to start our graph here, or else our graph would look kind of weird. You know, you'd have a graph that kind of like your first point's like way over here. Like, you don't want your first point to be like this. That would look kind of weird. So if you could just take those points and say, you know, make that 0, 0, it's going to look a lot better. It's going to be easier for you to model that. Just imagine you're in like a board meeting and you have to show this data, and you give them a graph that takes up half the room, and like 90% of that space is blank because you started your graph at 1988. That'd be kind of weird. So we're going to start at 0. All right, so when we plug in our data, we're going to go, same thing here. I'm going to go this one a little quicker. We're going to go stat edit, and let's type your data in. So we got 0, 2, 5, 7. So 0 I already have. So 2, 5, 7, 11, and 17. And then we're going to go to our y values and type those in. So that's going to be 1800, and then 2100, 5500, 9800, and so on, and 7000, and 16,000. Okay. So once we have our data in, remember we're going to go back to stat, we're going to go to calculate, and we're going to, in this case, they want us to do a quartic model. So we're going to go down to quartic regression, which is 7, and just hit enter until we get our equation. And there we go. So we have our equation. I'm not going to write this whole thing in because that would be kind of annoying. I'm just kind of showing you what you can do with it and how these things kind of give you the equation, how we can like translate it. But what we want to do though, we want to copy this into our graph. So let's go up here, let's clear our y equals, and we're going to plug in that equation. So we're going to go vars, statistics, equation, which is that right arrow, hit it twice, regression equation, and we have it copied. Okay. Now this one, again, if you notice, I didn't even read the question. I was just so kind of caught up in the steps here. But this table below shows the opening values of a stock market index on the first day of trading during certain years since 1988. So that's what this represents, and we want to estimate. And again, obviously it's already in 2010, but you know what I mean. We are estimating based off the data we have. What would it be in 2010 based off how it's been interacting so far? So we're using a mathematical model to make estimates about future behavior. So we have our equation already. We need to get our window, and we want to make sure our window goes out to 2010. So I'm looking here to 2010. That's 5 more years after 17. So that's going to be 22. So my domain starts at 0 and goes to 22. So we're going to go out a little bit further than that. I'm just going to go out to 25 just so I can make sure I can see it. And I'll go up by, I don't know, 5s. It doesn't matter really. But that just makes my tick marks. So I don't want to have too many of them there. So my y min, well, my y min, I'll start that at 0. But it looks like it goes as high as 16,000, but it might be going higher than that. So let's try to be safe here, because it looked like it's gone up quite a bit at the very end. And again, if you ever have your window where you maybe didn't make it big enough, you can always go back and change it. If you notice like, wow, I should go higher, then go higher. But it looks like it's really starting to take off. So I'm going to say 30,000, and that should hopefully fit my answer. And because I'm going up 30,000, I'll go up 10,000 for my tick marks. Again, it doesn't matter. I just want to give you some ideas and maybe what you can use there. Okay, so now we should be able to graph this. And again, if you ever don't see your plot points, make sure plot 1 is highlighted. And there's your model. It's fitting all those points. And there we go. And as I said, it's taking off. That's what it was looking like there at the end. So again, maybe my answer fits, maybe it doesn't. But we're going to go and estimate the value of the stock index in 2010. So I'm going to go second table, and I'm going to go not 2010. If I did that, by the way, it's going to give me this big error message. You know, this is like 6.5 times 10 to the 13th, because we're not going out 2010 years. We're going out 22 years after the initial time that this data started. That's 22 years after 1988. So that's why we're plugging in 22. And that's what we get. We get 123,621. So again, it wasn't even close to fitting. I knew it was taking off, but it just took off too quick there. But I can show you that if you want to see it here. But this is going to be in 2010. Estimate the value of the stock index. It's going to be approximately 123,621. I mean, that'd be nice if it went up that fast. But again, it's starting to take off at a certain point. So if you wanted to kind of get that window in there, if it followed that trend, again, we'd have to go out like 125,000. You know, so that would be that'd be pretty big here. You can kind of see it kind of level here and level, 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 and then all of a sudden, bam, there it goes. And you can kind of see like the little loops in there for the quartic equation and all that. It's just they're very minor compared to how it reacts later on. So anyway, at this point, hopefully it gives you an idea of how to model these, and sometimes the models are going to be, they fit really well, and sometimes they don't. You know, it really just depends on the data. And you know, the more data you have, the more accurate it'll get. And you know, these equations they're kind of, you know, they're very detailed, but the thing that you need to make sure you have a lot of is data. So the more data you have, the better. But again, this is going to model it based off what we have, and that's why this last one was probably a little high, just because we don't really have much data to go off of. We just have this one point where it seems like, oh, now it's exploding. And it's just going to say, well, I'm going to continue that trend because I have nothing else to tell me otherwise. So anyway, now that you have these answers, go ahead and make sure they get checked off, and you can go ahead and get started on your assignment. Thanks.